Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a video on lecture video and sample problem videos on internal forces and moments. This is in preparation to the construction of the shear, force, and bending moment diagrams, as well as the sketching of the elastic curve. So it is important that the free body diagram is correctly made, labeling all the internal forces and writing equations of statics to solve for these internal forces. And finally, and hopefully, you are able to prepare for problems where you can solve by your own and prepare for your quizzes and exams. I hope that this video will help you in your preparations as civil engineering students and allied engineering students in some aspect. So I hope so. For the beam shown, derive expressions for shear V and moment M and draw the shear force and bending moment diagrams. Neglect the weight of the beam. So here is the given figure. So let's have for the solution, let's call this By R sub C. Then Bx is 0, of course. So summation moment about C equals 0. So By times 6 minus 24 times 9 times 4.5. 4.5 from centroid to C equals 0. So By is equal to 162 kilonewtons. Likewise, summation moment about B equals 0. R sub C minus 24 times 9, 1.5. The distance of the centroid horizontally from B is 1.5. 4.5 minus 3 is 1.5. So that's it. So R sub C is equal to 54 kilonewtons. Then let's have the diagram to ready for shear and moment diagram construction. Let's put By, which is equal to 162 kilonewtons, R sub C 54 kilonewtons. So let's have this section here, AB, at distance x. So take note that shear is downward, positive direction, and moment is counterclockwise. So shear in this section is shear, because this is also downward, so it is negative 24 times x. Shear AB is negative 24 times x, applicable for 0 less than x less than 3 meters. Then for the moment, it was negative 24 times x. Then the moment arm is x over 2. So moment AB is negative 24 times x over 2. So negative 12x squared for 0 to 3 also. So I hope that you can imagine. But anyway, in the succeeding problems, I presented it in more details. For the meantime, you just imagine first. Next for segment BC. So shear is going down positive, then moment is BC is counterclockwise positive. So therefore shear is 162 minus the area of this loading 24 times x. Again, shear is 162 minus 24 times x. That is applicable for 3 less than x less than 9 meters. So 162 minus 24 times x, which is this. For the moment, 162 times this distance is x minus 3. So 162 times x minus 3 minus the moment of the load, 24 times x, moment arm x over 2. So therefore, the moment in BC is 162 times quantity x minus 3 minus 12x squared. So MBC is 162 times x minus 3 minus 12x squared. So 329. So that's it for the shear and moment equations. We are now ready to plot the shear diagram as well as the moment diagram. So for shear AB, when x is 0, negative 24 times 0 is 0. Then when x is 3, negative 24 times 3 is negative 72. Connect the 2 points by a straight line because this represents a straight line with negative slope. Then when x is for BC, so substitute x is 3 first, negative 24 times 3 plus 162, that is positive 90 as shown. Then when x is 9, negative 24 times 9 plus 162, it is negative 54. And connect them with a straight line because this is aligned with negative slope, negative 24. So that's it. And this is negative 54. So that's the shear diagram closest because the reaction here is 54. Then for the moment, by the way, this distance is obtained by, call this x1, by similar triangles. X1 as to 90 equals 6 minus x1 as to 54. Then you can solve for x1. But the best or shortest way to solve for x1 is shear 90 divided by load 24. So 90 divided by 24 is equal to 3.75. Again, these 3.75 meters can be solved in two ways. One, by similar triangles. X1 as to 90 equals 6 minus x1 as to 54. You can show that it is 3.75. But the shorter way is, it is shear 90 divided by 24. And it is 3.75. So the value of x here, where shear is 0, is 3 plus 3.75. So it is 6.75 meters, which is necessary in computing this maximum moment. Positive moment rather. So for moment, we begin with AB. When x is 0, negative 12 times 0 square is 0. When x is 3 meters, negative 12 times 3 square is negative 108. And we connect the 2 points with a curve which is concave downward because the slope or the coefficient of the second degree term is negative, so it is concave downward. Or the slope is increasing negatively. Or once you plot 0 and negative 108, instance negative 108 here, you just differentiate this twice and it is negative. Remember, the second derivative of a function is the concavity. So since the result is negative, second derivative is negative 24. Negative means concave downward. So that's the idea as of the moment. Then later on, we will interpret the curve or slope. There is relationship between the slope of the tangent to the moment curve and the shear ordinates above. Then that's for AB. For BC, when x is 3 meters, 3 to 9 applicability. So this is 0, so it's the same equation, negative 12 times 3 squared, so it is continuous, negative 108. Then when x is 3 plus 3.75 here, substitute 6.75 to compute the moment. 162 times 6.75 minus 3, then minus 12 times 6.75 square, you will get a value positive of 60.75. Then why do we connect the 2 points with this concave downward curve? Because again, the coefficient of the second degree curve in this function MBC is negative, or if you differentiate this twice, the result is negative, so it is concave downward as shown. Then finally, when x is 9, substitute here, 162 times quantity 9 minus 3 minus 12 times 9 square, you will get moment here 0. So connect 60.75 and 0 with a curve that is concave downward again, because same interpretation as before, the coefficient of the second degree term is negative. So that's it for the shear and moment diagram, and let's shade the diagram to look attractive. So that's it for this problem. Level 32, for the beam shown, derive expressions for shear and moment and draw the shear force and bending moment diagrams. Neglect the weight of the beam. So we have a cantilever beam. Actually, in the construction of this cantilever beam, we don't need to solve for the reactions at C, but to counter check, let's just solve them. So let's call the vertical reaction as Cy. The moment reaction, let's assume clockwise, although it is really clockwise and negative. So Cx0 and moment at C. Cy is summation versus y. So Cy minus 1/2 of 2 times 4 minus 3 times 4 equals 0. So C sub y is equal to 16 kilonewtons. Then M sub C is equal M sub C minus 1/2 of 2 times 4. The moment arm is 1/3 of 2, or 2/3 plus 3. So 2/3 plus 3. Then here at the centroid, the equivalent force is the area of this rectangle, 3 times 4. And the distance of the centroid from C is half of 3, 1.5, equals 0. So M sub C is equal to 32.667 kilonewton meter clockwise. So it is correct in the figure, the direction. So let's plot now. But before that, let's have the sectioning. So these are the reactions at C. Then at this distance x, shear is downward and moment is counterclockwise. So both shear and moment would be negative equation. So this is 1/2 of x times the intensity of the loading in terms of x. So let's call that W. So W as to x equals 4 as to 2. So W as to x, because this is x, equals 4 kilonewton per meter as to 2. So therefore W is 2x. So as I said, shear plus 1/2 of x times W, the area of this triangle, equals 0. So shear in this section AB is negative 1/2 of x times W, which is 2x. So shear AB is negative 1/2 of x times 2x. So it is negative x squared. Applicable for 0 less than x less than 2 meters. Then for moment, it is counterclockwise. Counterclockwise plus moment of the triangular load about this section, 1/2 of x times 2x. The moment arm is x over 3 equals 0. So moment is negative. So moment AB is negative 1/2 of x times W, 2x. Moment arm x over 3. Remember, centroid of triangle. So it is negative x cubed over 3, applicable for 0 up to 2. Then for the next section, at distance x, so shear is still downward, but this is now a whole triangle. So, but this one is, the length here is x minus 2. So summation versus vertical, shear plus 1/2 of 2 times 4 plus 4 times x minus 4 times quantity x minus 2 equals 0. So shear BC is negative 4, where negative 4 is the area of this triangle, 1/2 of 2 times 4, negative 4. Negative 1/2 of 2 times 4 is negative 4. Then the area of this triangle is, because it's going down, so minus 4 kilonewton per meter times x minus 2, the length, x minus 2, minus 2. So applicable for 2 to 5. Then moment BC is negative also, so it is negative 4 times 2/3, 1/3 of 2 plus x, sorry, x minus 2/3 of 2, 4/3, moment arm of negative 4. So negative 4 times this moment arm is x minus 4/3, 2/3 of centroid. So 2/3 of 2, 4/3 for moment later. But for shear, it is negative 4 and negative 4 times x minus 2. So simplifying that, that's negative 4x plus 4, shear BC. For moment BC, it is negative 4, the moment arm is x minus 4/3. So negative 4 is here, equivalent to this area. Then its moment arm, which is this distance, is x minus this distance. This distance is 2/3 of 2, or 4/3. Then minus 4 times x minus 2. This rectangle here, the centroid is at the center of the rectangle, so this distance is x minus 2 over 2. X minus 2 over 2. So minus 4 times x minus 2, area of this rectangle. Then moment arm x minus 2 over 2. Simplifying, moment BC is negative 4 times x minus 4/3 minus 2 times x minus 2 quantity square. So you can simplify, or you may just leave this answer in that way. Anyway, we can still plot the shear and moment diagram. So for the shear, substitute in AB. First, x is 0, negative 0 square, so it begins with 0. Negative, when x is 2, negative 2 square is negative 4. Connect 0 and negative 4 with a concave downward curve, because the coefficient, this is second degree curve, is negative. Same explanation as before. The concavity is negative. Then for BC, this one, the simplified form, when x is 2, first 2 at B, negative 4 times 2, negative 8 plus 4, so it's still negative 4. Then when x is, this is a straight line with negative slope. When x is 5 at C, negative 4 times 5, negative 20 plus 4, so it's negative 16. Since this is a straight line with negative slope, so we connect negative 4 and negative 16 with a straight line, as shown. So that's it. So because the reaction there is 16. Then for the moment diagram, first AB, negative x cubed over 3, when x is 0, 0. When x is 2, negative 2 cubed over 3, negative 8/3. So again, negative 8/3 and 0 must be joined with concave downward curve, because the coefficient of this third degree curve is negative. So if you differentiate this twice, the concavity is negative. Then for BC, this is the formula. When x is 2, substitute here. So this is 0. So negative 4 times quantity 2 minus 4/3, that's 2/3. So 2/3 times negative 4, so it's also negative 8/3. So it is continuous. When x is 5, substitute here, x is 5, and you will get negative 32.6667. So connect negative 8/3 and negative 32.667 with a concave downward curve again, because the coefficient of this is first degree, second degree curve is uh, negative, so the concavity is concave downward. So you may shade, you may not. So that's the shear and moment diagram. So let's shade the figure. So that's the shear and moment diagram. Level 33 for the beam and loading shown. Derive expressions for shear and moment and draw the shear force and bending moment diagrams. Neglect the weight of the beam. Also determine the maximum absolute values of the shear and bending moment. So here is the given figure. So for the solution, let's solve for the reactions AY, AX is 0, and RB. Summation moment B equals 0, AY times 5 minus 60 times 3 minus 25 times 2 times 1 equals 0. So AY is 46 kilonewtons. Likewise, summation moment about A equals 0, R sub B times 5 minus 60 times 2 minus 25 times 2 times 4 equals 0. So R sub B is 64 kilonewtons. So you notice that I always compute reactions by taking moments about a point. I'm not using summation versus Y immediately, because if one reaction is wrong and you sum up forces vertical, the other would also be wrong, definitely. So you only check your answers after the moment equations. 46 plus 64, that's 110, minus 60, 50, minus 25 times 2, so 0. So that checks. So for the shear moment diagram constructions, for the details, so let's have here the reactions. And this time I'll solve this in more detail so that those who are weak can follow. So this is the first section, and this is the free body diagram. So we have 46 upward, shear downward, which is positive, and distance is x, and moment is counterclockwise as shown. Therefore, summation versus y, shear is 46 for section AC from 0 to 2. So shear is 46, obviously here, and moment is 46 times x. So that's the equation. Applicable for AC only, or 0 less than x less than 2. Then for the next section, let's have the details. Distance from A to that section is x, as shown here. So reaction 46, shear moment, positive direction, then x. So this distance is x minus 2, moment arm of 60. So for CD, summation versus y, shear is 46 minus 60, so negative 14, constant. And the moment is 46 times x minus 60 times x minus 2. This is x minus 2. So moment is 46 times x minus 60 times quantity x minus 2. Simplifying, moment is negative 14x plus 120. And this is applicable from 2 to 3 equation, or CD only. Then for the next section, we have another segment. So I'm not drawing the free body diagram anymore for the portion to the left of that section because we ran out of space. We can also have the section to the right. This is another way, and the result is the same. So let's just imagine this is the section. So shear in this section is considering forces to the left, and the distance is x from A. So this is the free body diagram to the right of that section. So shear is upward this time, positive. So this is 5 minus x because this distance is x. The total length AB is 5. So therefore, this is 5 minus x, as shown in the figure. So that's a positive shear, which is upward. And the positive moment is, remember the sign convention, is clockwise at the left. So at the right section, down for positive shear, counterclockwise moment, because this is the right section if you consider A and that section. So first, let's establish shear equation considering forces to the left. So by the way, the area is 25 times length 5 minus x. Then this distance is x, 5 minus x over 2. That's 5 minus x over 2. So for dB, the shear is 46 minus 60, considering forces to the left. So 46 minus 60 minus the area of this triangle, rectangle here, 25 times x minus 3, because this is 3 meters, so this is x minus 3. So minus 25 times x minus 3. Remember, this is considering the free body diagram to the left of this section. So simplifying, it is negative 25x plus 61. You simplify this equation. Then for the moment, it is 46 times x, then minus 60 times quantity x minus 2, then minus, remember, 25 times x minus 3, moment arm x minus 3 over 2, so minus 12.5 times x minus 3 square. Again, considering the forces to the left of this section, the moment at this section is 46 times x minus 60 times quantity x minus 2. Then moment of this rectangular loading, 25, the length is x minus 3, and the moment arm x minus 3 over 2. So that's why it reduces to 25 over 2 or minus 25 over 2 or negative 12.5 x minus 3 square. Simplifying, moment is negative 14x plus 120, then minus 12.5. The expansion of x minus 3 quantity square is x square minus 6x plus 9. Simplifying further, moment is negative 12.5 x square plus 61x plus 7.5. Now, if we consider the simpler free body diagram, which is this, the moment equation is moment clockwise equals counterclockwise moment minus clockwise moment. So clockwise equals counterclockwise moment. So moment, therefore, in section dB is 64 times 5 minus x. So that's the applicability. So shear first is upward equals downward. Therefore, the shear equation in dB is downward minus upward. So shear is 25 times 5 minus x. So this is sum of forces vertical. Shear plus 64 equals 25 times 5 minus x. So shear is 25 times 5 minus x minus 64. Considering this free body diagram. So first, let's plot. We will just verify that later. So let's plot the shear diagram. So for AC, when x is 0, shear is 46. When x is 2 meters, because this is from 0 to 2, it is also 46, so constant. Then for portion CD, this is the shear equation, negative 14. When x is 2, negative 14, as shown. Then it is also negative 14 when x is 3, up to 3. Then for dB, the shear equation is negative 25x plus 61. When x is 3, negative 25 times 3, negative 75 plus 61 is negative 14. When x is 5, negative 25 times 5, negative 125 plus 61 is negative 64. And it's negative 64 here. Now, why do we connect these 2 points with a straight line? Because this is a line with negative slope, negative 25x plus 61, the slope is negative 25. So that's why we connect them with a straight line. So that's the shear diagram. Then for the moment, when x is 0, 46 times 0, it's 0. When x is 2, 46 times 2, so this is 92. For BC, for CD rather, this is the formula for moment, which is a straight line with negative slope. When x is 2, negative 14 times 2, negative 28, plus 120, so it's still 92 for portion CD. Then when x is 3, 2 to 3, negative 14 times 3 plus 120, connect with a straight line. So it is 78. Then we connect with a straight line because this is aligned with negative slope. Then finally, when x for dB, when x is, this is the formula. When x is 3, begin with 3 first, substitute here. The answer is 78. Then when x is 5, substitute here. The moment would be 0. So this is the equation considering this free body diagram. So shear is downward minus upward. So downward 25 times 5 minus x minus upward 64. Simplifying, shear in dB is negative 25x plus 61, which is the same equation here, even if we consider this free body diagram. So that's a technique. If there are many forces considering the left section, then proceed to the right section if it is simpler. Anyway, we will show here that the equations are the same. Now for the moment, this moment is clockwise positive. So clockwise moment equals counterclockwise moment. Therefore, moment equals counterclockwise moment. So 64 times 5 minus x minus 25 times 5 minus x times quantity 5 minus x over 2. So moment is 64 times 5 minus x minus the moment of this load, 25 times 5 minus x times 5 minus x over 2. 25 times 5 minus x times 5 minus x over 2. Simplifying, moment is 320 minus 64x minus 12.5 times 25 minus 10x plus x squared. So combining like terms and simplifying, you will get the same result as this. So there's no problem if you consider forces to the left of the section or forces to the right of the section. Whichever is simpler, then you can establish shear and moment equations and expect the same results, just like this. So I hope that you gain confidence when you write shear and moment equations at various sections and select the simpler free body diagrams. You just remember the positive sign convention for shear and moment. So when x is 5 in this equation, it is 0 as shown. Now why do we connect them with a concave downward curve? It's because again the coefficient of the second degree term, the degree of this moment curve, is negative. So it is concave downward. Then we shade the shear and moment diagrams. The absolute shear is 64 and the absolute maximum moment is 92 kilonewton meter. So let's shade the diagram for best figure. So that's it for this problem. So level 34, for the beam and loading shown, derive expressions for shear and moment and draw the shear force and bending moment diagrams. Neglect the weight of the beam. Also determine the maximum absolute values of the shear and bending moment. So here's the given figure. First, we have AY, AX is 0, then R sub D. So summation moment D equals 0, AY times 4 plus 20 times 2 times 1 minus 50 times 2 equals 0. From there, AY is 15 kilonewtons. Then summation moment about A equals 0, RD times 4 minus 50 times 2 minus 20 times 2 times 5. So distance from centroid to A is 5 equals 0. So R sub D is equal to 75 kilonewtons. So we are now ready to plot the shear moment diagram and write shear moment equations per section. So we have to apply the reaction 15, RD is 75 as shown. Then let's have the sectioning in AC first. Then this is the distance X, free body diagram. So that's the shear, then moment is counterclockwise, positive. So therefore, summation versus Y, shear equals 15. For portion AC, which is 0 to 2, shear is 15. Then for the moment, it is 15 times X, which is a straight line with positive slope. Then for the next section, this is the free body diagram, considering forces to the left, we have 15 upward. Then that distance is X, shear moment positive. So that is X, therefore this is X minus 2. So shear equals 15 minus 50 for CD, which is 2 to 4. Shear is 15 minus 50 or negative 35. Then moment is 15 times X minus 50 times X minus 2, quantity X minus 2. 15 times X minus 50, quantity X minus 2. Simplifying, the moment equation is negative 35X plus 100. And that is applicable for CD only, or 2 to 4. Then for the next section, which is here, you may consider portion or forces to the left, which are so many. You may consider FBD to the right. So let's consider left and right and show that they are the same in this problem. So 15, then we have 75 at D, then shear downward positive, so call that X. This is X minus 4, then that's the equivalent force acting at the centroid of the rectangle. Intensity 20 times length X minus 4. Its distance from the right is X minus 4 over 2. From the left, that D, X minus 4 over 2 also. Positive shear is downward, moment is counterclockwise. So shear is previous negative 35, then plus 75 minus 20 times X minus 4. So 4 to 6, shear is previous shear negative 35. The new forces here, so plus 30 plus 75, then minus 20 times X minus 4. So simplifying, shear is negative 20X plus 120. Then for the moment, previous negative 35X plus 100 times the new moment, we have 75 times X minus 4, which is this. So this is the moment in the previous segment. You just add the changes, which are 75 times X minus 4 and minus 20 times X minus 4 times X minus 4 over 2, the moment arm. That's why it reduces to negative 10 X minus 4 squared. This is originally minus 20 times X minus 4. Moment arm X minus 4 over 2, so 20 over 2 is 10. So that's why it becomes like that. So simplifying further, moment is 40X minus 200 minus 10. Let's expand this. X squared minus 8X plus 16. So moment is negative 10X squared plus 120X minus 360 if you simplify this moment equation. Now, if we use the free body diagram, considering the right section as shown, then shear is upward, moment is clockwise, positive moment. And the force is, this is 6 minus x, so that force is intensity 20 times base 6 minus x. The moment arm is 6 minus x over 2. So upward shear equals downward shear. So shear is 20 times 6 minus x. And if you simplify that, that's the same shear equation here, which is negative 20x plus 120. But simpler and easier. Then for moment, moment plus 20 times 6 minus x times 6 minus x over 2, it's negative. So moment plus 20 times 6 minus x, moment arm 6 minus x over 2 equals 0. Summation moment about this section, considering this free body diagram. So it is negative 10, quantity 6 minus x squared. 6 minus x squared, if expanded, is 36 minus 12x plus x squared. Simplifying further, it should be the same as this. So negative 10x squared plus 120x minus 360. So they are equal. But this equation is simpler for this free body diagram. So we now plot the shear diagram. So first for AC, it is 15. It is 15. Then constant, when x is 2, it is also 15. So for AC, it's entirely 15. For CD, when x is 2, it jumps to negative 35 directly. So negative 35 here. Then when x is 4, it's still negative 35 because it is 2 to 4. So horizontal, negative 35. Then for dB, D to B, this is the shear equation. First, when x is 4 at D, negative 20 times 4, 80 plus 120, it's 40. So positive 40 directly there. Then when x is 6, negative 20 times 6, 120 plus 120, 0. This is a straight line. So 0 here and 40 there should be connected with the straight line as shown. So that's the shear diagram. For moment, AC, it is 15x. When x is 0, 15 times 0 is 0. When x is 2, 15 times 2, so this is 30. Then for CD, this is the formula. When x is 2, negative 35 times 2, negative 70 plus 100, so it's still 30. When x is 4, negative 35 times 4, negative 140 plus 100, negative 40. So negative 40 and 30 must be connected with a straight line because this is a line, a straight line with negative slope. So negative 40 here. Then when x is, we are now in dB, this is still the, moment, dB. This is the formula. When x is 4, negative 10 times 4 square plus 120 times 4 minus 360, it should be negative 40. Then when x is 6, negative 10 times 6 square plus 120 times 6 minus 360 should be 0. And we should connect 0 and negative 40 with a concave downward curve because the coefficient of the second degree term is negative. So it is concave downward. So this is the shear and moment diagram. The absolute maximum shear is 40. Let's shade it. Let's shade them first. And the maximum absolute moment is also 40. So shear max 40, moment max 40 kilonewton meter also. Level 35, for the beam and loading shown, derive expressions for shear and moment, and draw the shear force and bending moment diagrams. Neglect the weight of the beam. Also determine the maximum absolute values of the shear and bending moment. So here is the figure. Let's have the reactions AY and AX is 0, then RB. Summation moment B equals 0. AY times 1 plus 2 times 0.5 minus 1.6 equals 0. So AY is equal to 0.6 kilonewton. Then summation moment A equals 0, RB times 1 plus 1.6 minus 2 times 1.5 equals 0. So R sub B is 1.4 kilonewtons. So 1.4 plus 0.6 equals 2. So it checks. So we have AY 0.6 kilonewton, RB 1.4 kilonewton. So let's have the first section there. Then draw the free body diagram. Assign the positive shear and moment. So therefore, for this section 0 to 6, 0 to 0.5, shear is 0.6. So the shear equation is constant 0.6. Then moment is 0.6 times x. Just take moment here, so 0.6 times x, clockwise positive, remember. Then, or clockwise equals counterclockwise moment. Then for the next section, this is the free body diagram considering the forces to the left. So positive shear is called the distance x, positive shear is downward, moment is counterclockwise. So shear equals 0.6. So no change because this is a couple. So for 0.5 up to 1, shear is still 0.6, but the moment is 0.6 times x minus 1.6. So 0.6 times x minus 1.6. That's the moment equation. Then for the last section here, you may consider the left FBD and the right. So by experience, let's consider the right. Anyway, the result is the same. And I hope that you already gain confidence of writing shear moment equation considering the simpler free body diagram, which is this one. So shear is upward, positive. This is 1.5 minus x because this distance is x. The entire length is 1.5, so that's 1.5 minus x. So shear is upward, moment is clockwise. So shear minus 2 equals 0. So therefore the shear equation for the last segment 1 to 1.5 is 2. So the shear equation is 2. The moment equation, moment plus 2 times 1.5 minus x equals 0. So moment is negative 2 times quantity 1.5 minus x. So moment plus 2 times quantity 1.5 minus x equals 0. So moment is 2x minus 3. So that's the equation for the last segment. So let's plot now the shear and moment diagram. When x is 0, it's 0.6. 0.6 up to there. When x is 0.5, it's also 0.6. Then 0.5 to 1. When x is 0.5, it is still 0.6. When x is 1, it is still 0.6 as shown. Then for 1 to 1.5, the shear is 2. So it jumps to 2 when x is 1.5. 2. When x is 1 rather, it is 2. Then when x is 1.5, it is still 2. So horizontal. So that's it. That's why minus 2 is 0. Then for the moment equation 0 to 5, 0.6x. When x is 0, 0.6 times 0, so it begins with 0. This is a straight line with positive slope. When x is 0.5, 0.6 times 0.5, so it's 0.3. Then connect the 2, 0, and 0.3 with a straight line because this is aligned with positive slope. This is also aligned with positive slope. When x is 0.5, 0.6 times 0.5 is 0.3 minus 1.6, so negative 1.3. It jumps to negative 1.3 here. Then when x is 1, because this is applicable from 0.5 to 1, 0.6 times 1 is 0.6 minus 1.6 is negative 1. Negative 1 and negative 1.3 must be connected with a straight line. The slope is positive, so this is negative 1. Then finally, from 1 to 5, this is the moment equation. When x is 1, 2 times 1, 2 minus 3 is negative 1. So it's the same. When x is 1.5, 2 times 1.5, 3 minus 3, 0. So negative 1 and 0 must be connected with a straight line again because this is a line. So that's it. Then shade. To look attractive. Then the absolute maximum shear from the figure is 2 kilonewtons. The absolute maximum moment is 1.3 kilonewton meter. So that's it for this video. It's lengthy because of long solution and detailed discussion. So I hope that you were able to follow, especially the last part where I solved the problem with detailed free body diagram so that you can follow.